From a distance, Venus appears as a brilliant jewel in the night sky, outshining all other celestial bodies except the Sun and Moon. Its radiant presence has fascinated humanity for centuries, inspiring countless myths and legends. Ancient civilizations often associated Venus with deities of love and beauty, captivated by its steady, unwavering glow. This celestial neighbor, often called Earth's twin, captivates us with its ethereal glow. The planet's thick, reflective clouds contribute to its bright appearance, making it a prominent feature in our sky. Despite its beauty, Venus remains shrouded in mystery, its surface hidden beneath a dense veil of clouds. But beneath this alluring facade lies a planet of stark contrasts and scorching extremes. The surface of Venus is a hostile environment with temperatures soaring to levels that can melt lead. The planet's atmosphere is a swirling mix of toxic gases, creating a landscape that is both fascinating and forbidding. Venus, while similar in size and composition to Earth, harbors secrets that challenge our understanding of planetary evolution. The differences between the two planets are a stark reminder of the diverse paths that planetary development can take. Scientists continue to study Venus to uncover the mysteries of its past and what it can teach us about our own planet's future. Its thick atmosphere, composed primarily of carbon dioxide, traps heat with relentless efficiency, creating a runaway greenhouse effect. This phenomenon has transformed Venus into a pressure cooker, with surface pressures over 90 times that of Earth. The planet's atmosphere is also rich in sulfuric acid, adding to its inhospitable nature. This has led to surface temperatures hot enough to melt lead. The extreme heat and pressure make Venus one of the most challenging environments for exploration. Despite these conditions, missions to Venus have provided valuable data, revealing a world that is both alien and eerily familiar. The similarities between Venus and Earth are intriguing. Both planets occupy the inner region of our solar system, often referred to as the terrestrial planets. Their proximity to the Sun and similar sizes make them natural subjects for comparative study. Both planets are almost identical in size and mass. Venus is only slightly smaller than Earth, with a diameter about 95% that of our home planet. This similarity extends to their masses, with Venus having about 82% of Earth's mass. They share a similar internal structure, with a rocky mantle and a metallic core. These internal similarities suggest that Venus and Earth may have formed from similar materials in the early solar system, yet their evolutionary paths have diverged dramatically. Their compositions, rich in silicate rocks and metals, further emphasize their kinship. The surface of Venus is covered with vast plains of volcanic rock, punctuated by mountains and highland regions. These features hint at a geologically active past, with volcanic activity playing a significant role in shaping the planet's surface. These shared characteristics make the stark differences between the two planets even more striking. While Earth is a haven for life with its moderate temperatures and abundant water, Venus presents a vision of a world gone awry. Understanding these differences helps scientists piece together the complex puzzle of planetary evolution and the factors that make a planet habitable. Venus's atmosphere sets it apart from Earth in a dramatic fashion. Unlike our planet, Venus is shrouded in a dense, toxic atmosphere that creates a hellish environment, composed primarily of carbon dioxide, 96.5%, with a smattering of nitrogen, 3.5%, and trace amounts of other gases. It acts as a massive thermal blanket. This thick layer of gases traps heat with incredible efficiency, making Venus a true inferno. This dense atmosphere traps solar radiation, leading to a runaway greenhouse effect. The sunlight that penetrates the clouds is absorbed by the surface and then re-emitted as infrared radiation, which is trapped by the thick carbon dioxide layer. This phenomenon has resulted in Venus having the hottest surface temperatures of any planet in our solar system. The average surface temperature is a scorching 467 degrees Celsius, hot enough to melt lead. The atmospheric pressure on Venus is equally extreme, reaching 92 times that of Earth's surface pressure. This immense pressure is due to the thick atmosphere and the heavy gases that compose it. This crushing pressure is equivalent to being 3,000 feet beneath the ocean's surface on Earth. Such conditions would be fatal to humans and most known life forms. The thick clouds of sulfuric acid that blanket the planet are another defining feature of Venus's atmosphere. These clouds are highly reflective and contribute to the planet's extreme brightness when viewed from Earth. These clouds reflect sunlight back into space, giving Venus its high albedo and contributing to its extreme brightness. This reflective quality makes Venus one of the brightest objects in our night sky, often visible to the naked eye just after sunset or before sunrise. Beneath this thick, toxic atmosphere lies a surface marked by volcanic activity and vast plains of solidified lava. The volcanic activity releases more carbon dioxide into the atmosphere, perpetuating the greenhouse effect. The extreme conditions of Venus's atmosphere pose significant challenges for spacecraft. The high temperatures, crushing pressures, and corrosive clouds make it incredibly difficult for any lander to survive for long. Despite these challenges, past missions like the Soviet Venera program have provided valuable data. Future missions aim to further explore this enigmatic planet, unlocking more of its secrets. Landing on Venus is an endeavor fraught with challenges. The extreme heat, crushing pressure, and toxic atmosphere create a hostile environment for any known life form. The surface temperature, averaging a scorching 464 degrees Celsius, 867 degrees Fahrenheit, is hot enough to melt lead. This intense heat makes Venus uninhabitable for humans and presents a significant obstacle for robotic exploration. The dense atmosphere also plays a role in shaping the Venusian landscape. While Venus lacks the kind of plate tectonics that shape Earth's surface, its thick atmosphere distributes heat remarkably evenly. This results in relatively small temperature differences between the planet's equator and its poles, despite its slow rotation. Venus exhibits a peculiar characteristic that sets it apart from most other planets in our solar system. It rotates retrograde. This means that, unlike Earth and most other planets, Venus spins in the opposite direction. This retrograde rotation means that Venus spins on its axis in the opposite direction to most planets, including Earth. While Earth and many other planets rotate counterclockwise when viewed from above their north poles, Venus rotates clockwise. While Earth rotates from west to east, causing the sun to rise in the east, Venus rotates from east to west. This unique rotation pattern results in some fascinating phenomena on Venus. On Venus, the sun would appear to rise in the west and set in the east. Imagine standing on the surface of Venus and watching the sun move across the sky in the opposite direction to what we experience on Earth. Another intriguing aspect of Venus's rotation is its incredibly slow speed. Venus takes an exceptionally long time to complete one full rotation on its axis. A single rotation on Venus takes 243 Earth days, making a Venusian day longer than its year. This means that if you were on Venus, you would experience a day that lasts for more than half of an Earth year. A year on Venus, the time it takes to orbit the Sun, is 225 Earth days. This is shorter than the time it takes for Venus to complete one rotation on its axis. This means that a day on Venus is actually longer than its year. The slow rotation and retrograde motion of Venus make it one of the most unique and fascinating planets in our solar system. Scientists continue to study Venus to understand the reasons behind its unusual rotation and what it can tell us about the formation and evolution of planets. Understanding Venus's rotation helps scientists gain insights into the dynamics of planetary systems and the forces that shape them. The study of Venus also provides valuable information about Earth's own past and future, as both planets share similar sizes and compositions. Despite its similarities to Earth, Venus has a harsh environment with extreme temperatures and pressures, making it a challenging target for exploration. However, its unique rotation continues to captivate scientists and space enthusiasts alike. Future missions to Venus aim to uncover more about this enigmatic planet, shedding light on its mysteries and deepening our understanding of the solar system. Venus's unique rotation is just one of the many intriguing aspects that make it a subject of ongoing fascination and study. While the thick atmosphere obscures our view of Venus's surface, radar mapping by spacecraft has revealed a diverse and dynamic landscape. Venus is dominated by vast volcanic plains, evidence of its geologically active past. These plains are dotted with thousands of volcanoes, some of which scientists believe may still be active today. In addition to the volcanic plains, Venus boasts towering mountains, rift valleys, and vast impact craters. Maxwell Montes, the highest peak on Venus, reaches a height of 8.8 kilometers or 5.5 miles, comparable to Mount Everest on Earth. These features provide clues to the powerful geological forces that have shaped Venus over billions of years. While the surface of Venus is undeniably inhospitable to life as we know it, the planet's upper atmosphere presents a tantalizing possibility. At an altitude of about 50 kilometers or 30 miles, temperatures and pressures are surprisingly Earth-like. This region, with its moderate conditions, could potentially harbor microbial life. Scientists have detected intriguing anomalies in Venus's atmosphere, such as the presence of phosphine gas, which could be a biosignature. While these findings are preliminary and require further investigation, they raise the exciting possibility that life may exist in this unexpected environment. Venus has been a prime target for space exploration since the dawn of the space age. The former Soviet Union's Venera program, active from the 1960s to the 1980s, achieved remarkable feats. Venera probes were the first to land on another planet and transmit data back to Earth. These missions provided invaluable information about Venus's atmosphere, surface conditions, and geological features. NASA's Magellan mission, launched in 1989, used radar mapping to create the first global high-resolution map of Venus's surface. This mission revolutionized our understanding of Venusian geology and revealed the planet's diverse landscape in unprecedented detail. More recently, the European Space Agency's Venus Express mission studied the planet's atmosphere and climate for nearly a decade. Thanks for watching. Don't forget to comment, like, and subscribe to keep updated with our next video. Click on the screen now to go to one of our other videos or playlists.